All right, what I want to do is talk about treating bonds as a loan and why would you ever want to do that? Well, you can often deduct interest paid on a loan off of your taxes. So when you issue a bond, if you're a company, then you want to know how much interest you've paid off, treating the bond as a loan. Right. And bonds are loans, right? You're a corporation, you're a municipality or the US government, you need money. You issue a bond to get that money, so people pay you to get coupons and then redemption at the end. So they are essentially loaning you money. You, the corporation, municipality, United States, or whatever country that needs money. So to me, this is much more of an accounting topic. I'm not sure why it's tested on Exam FM, but it is, and henceforth we're doing it. I mean, to be clear, it's extremely practically useful, and we'll illustrate that by showing you how to do these amortization um, calculations very quickly on the EA2 plus. Anyway. All right, so yeah, here's our bond time diagram. F is the par value, C is redemption, R is my actual coupon rate. So we get FR at the end of each period, usually 6-month periods. And then we get redemption back at the end. So just plopping into our formula, and it should be, of course, you know, the loan interest rate is not really called the interest rate, it's called the yield rate when we're talking about bonds, that absolutely make clear we're not talking about the coupon rate, that. But yeah, so he's there. Here's our payments, coupons, except at the very end, coupons plus redemption. And so just plopping into our prospective method formula, we get the following. And this really, of course, is just the present value of the following time diagram at time t. So we discount FR once, and remember what VJ is. It's just the present value factor with respect to J. Because we have two rates, coupon and yield rate. So it's just 1/1. All right, so yeah, this discount, this coupon once, this coupon twice, this coupon discount 3 times is not here. Discount this coupon n minus t times, that's the last one here. So this whole thing here, of course, is n minus t periods, and then discount redemption by n minus t periods. So because this is just the present value of the following time diagram at the beginning, where the beginning here is t equal, well, it's just t instead of time t rather instead of t times 0. The beginning here is time t instead of time 0. But because this is just the present value of the following time diagram at the beginning, treated as time t, we can use our annuity formula. So this is just FR AN minus t, because n minus t periods, and then present value of redemption. Right? And actuaries call this book value for some strange reason. Why? They can't just call it outstanding balance. They could, but I don't know why they don't. But all right, so what that tells me is that, well, this definition of interest owed, this J times 100% of your prior outstanding balance, interest owed at the end of 2 periods. So yeah, where does this come from? I'll try to do this really quickly. So remember, we just had a formula for the outstanding balance. And that is F R A. Usually it's n minus t, but I'm plugging in t minus 1, so it's n minus t plus 1. and then discount redemption by, again, so t periods, it's t minus 1, so it's n minus t plus 1. Right, and of course, what is this here? This is just FR1 minus VJ n minus t plus 1 over j. That yeah, so the j's cancel, so that's basically what's going on. Get this nice simplification here. F R, j's cancel, 1 minus Vj n minus t plus 1. C, j doesn't cancel. N minus t plus 1. A little messy, but n minus t. Okay, and last but not least, you can I'm not going to do it, but you can just do a little bit of algebra and just take KT, which is FR, subtract this right here, and you're going to get the following. So again, it's just a little bit of algebra from what we just had above. So yeah, just take basically FR, subtract this here. You're going to get the following, add C, get this here. Because the payment is FR unless we're at the end when payment is FR and redemption. All right, so we'll go back to the formulas in a second. So just be aware of actuarial terminology versus accounting terminology. I don't know why accounting even needs to have different terminology, but they do. So the outstanding balance is called the book value, and accounting is called the net book value. Principal or paid can be one of two things: amount or amortization of accumulation of premium discount. Sorry, the amount for amortization of premium discount, or the amount for so yeah, the principal or paid is one of two things. It's either the amount for the amortization of premium slash discount, or the amount for the accumulation of premium slash discount. Premium slash discount means depending on if the bond is bought at a premium or a discount. Okay. So one thing to be aware of is if you go back, you'll maybe remember that the bond is bought at a discount precisely when FR is less than CJ, par if FR equals CJ, and at a premium if FR is bigger than. So remember, bond being bought at a discount means that the price is smaller than redemption, par is price equals redemption, and the premium is price is bigger than redemption. So, so yeah, when you buy a bond, interest is often capitalized. In particular, the principal or paid is always going to be positive precisely when the FR is bigger than CJ. Principal or paid is going to be negative. Sorry, it's going to be 0. So you never chip away at your outstanding balance if FR equals CJ. And that kind of makes sense because that means the price equals redemption. So the bond amount is redemption, and you don't touch interest. Sorry, you don't touch you don't touch principal until the very end where you pay it all off. You just make interest payments. So your coupon payments are just interest payments. In that very special case of FR equals CJ. And right, when FR is bigger than CJ, your principal paid is positive. So when the bond is bought at a premium, the principal paid is positive. And we'll see an example of a bond bought at a premium. And we'll check that the principal paid is each going to be positive. And yeah, 1 second. We just want to show you this in the sample exam FM questions. Just for you to be aware of. Just happened. Just loaded it, but in a second. So this takes a minute to search why. Console laptop. Yeah. So like here, it's the amount for accumulation of discount. Here, it's the amount for amortization of premium, amount for the accumulation of discount, amount for accumulation of discount. And here's the amount for the amortization of. So you could see both of them, either one, be aware of that. Okay, so let's do this example here. Verify this row. So this table needs some explanation. This is taken from an accounting book, intermediate accounting, so something you do like junior, senior level of accounting major. And so here the bond is bought at par, so face value is going to be the same as redemption. Yield rate is 3%. Coupon rate is 4%. And yeah, so we're going to verify everything here. So what's up with this here? So it's a 5-year bond, 10 6-month periods. So in accounting, you have to update books all the time because accounting law changes very often. So rather than sticking like a concrete year to these dates and having to update it to not make the book look outdated, they just call it generic X1 to X5 so that you don't know when this was. It makes kind of sense. And you can ignore this column here. This is just the outstanding balance at the beginning of each period. That's silly, but this is the outstanding balance at the end of each. Okay, so as a sanity check, let's get the present value, and that should be this here, the outstanding balance at the beginning of the first period, which is December 31st, X0. So coupons are 100,000 times R2 over 2.04, so it's 1,000. 10, and the yield rate is 6% over 2, 3%, 100,000 redemption. So yeah, 108, 530, exactly what I have. Well, here's a 0. Because they round up to the nearest dollar for some reason for the bond price. Anyway, so yeah, let's just plop into our formulas. And right. Try to do this quickly. So 100,000 redemption value. As I said before, R is 0.04, so coupons is 1,000. Right. So R 0.04, and lastly J 0.03, and is 10. So yeah, let's get the book value. So really, here it's FR is 4,000, redemption is 100,000. So really, the easiest thing is to get the present value as a time diagram rather than just use the formula. So I'll do that actually. So yeah, 4,000 payments. This is 8 to 10, so 2 and n minus 10 minus 2 is 10. 3%, 1,000. Redemption. Speed that up a bit. You redo that. So 2n, 3% interest, 4,000 payment, 100,000. That redemption. I don't know what I did there before, but so we get the right answer. And so they always round things to the nearest penny, and they do things recursively. So their error accumulates. So we're actually more accurate than them. They get 101, 9, 13, 21. They're off by 26 cents. Pretty damn close. And if you just want to plug and chug into a formula instead of remembering that this here is a present value. This time diagram from 8 to 10, it's fine. We'll get the same answer, which is what rand is. Should. So 2, 10 minus 2, sorry, 10 is n minus 8. T is 2, 3 interest, 4,000 coupons, redemption 100,000, present value. I don't think I cleared TBN, so there's no redemption for FRA 2.03. And 3 interest, 4,000 payment, compute present value, plus this present value of redemption. Get the same answer, 101, 9, 13, 47. Again, we're more accurate. Okay, so for interest owed, plug and chug here now. Again, FR is 4,000. So it might be worthwhile to get this here, save it. So FR is 4,000. So this plus 1. So raise this to the third. This times 4,000 plus redemption times 0.03 times this here cubed, and we get our answer 30845. And last but not least, so F equals C. So of course, to get the principal or pay, you could just take 4,000 minus this, and 9, 15, 14 off by a penny. But if you want to just plug into the formula, that's fine. So I would get FR minus CJ first. So it's 100,000 times 0.04 minus 100,000 times 0.03 times VJ cube. And I should say, sorry, it's cubed because n minus t plus 1. It's 10 minus 8 plus 1 is. So you get 915. And if you want to look this up in accounting, this is called the effective interest amortization. something like that. Accounting finance, so you'll see a lot of finance stuff. But yeah, we'll quickly yeah. All right, so remember our original definitions. Right. So yeah, the interest owed is just J times 100% of your prior outstanding balance. Principal paid is just payments minus the interest. The outstanding balance is your prior outstanding balance minus the principal repaid. So let's just do the previous problem, assuming the previous 6 months. So we want to get this row, assuming this row. Easy enough. 102,828, 36 times 0.03. 3% of my prior outstanding balance is 30,84.5. 4,000 minus this. Yeah, pay off interest first. 915.15. Take your prior outstanding balance minus this. Prior outstanding balance 102,828. 6, 101,913.20. Right? And this is important to remember kind of your definition, how loans work when doing certain exam FM computation. Be aware. Uh, second, right. So yeah, these calculations are so ubiquitous in real life that the calculator can do these super quickly without entering any formulas. So how do we particularly get the example we just did? Well, what we do is input all the needed information. Calculator, particularly get the present value. So and 3% interest, 4,000 coupon payments, 100,000 redemption, compute value, and just like before, 108,530 off by 20 cents. Fine. Okay, so what we do next is we hit the amortization key, second PV, the amortization, right? And we want the information for the 8th row. So we're starting at the 8th period and ending at the 8th period. We'll see what happens when we don't have the same starting and ending. And now we just go with the down arrows, and hopefully that'll give us the correct information. Well, again, outstanding balance, they're off by 26 cents. 101,913.47 versus 101,913.1. And this is what you owe, so that's why it's negative. And not subtly, the calculator has balance for outstanding balance. Not subtly, the calculator has principal for the principal repaid. 915.14 off by a penny. And interest, and for interest, 308,486 off by. And this actually works for loans too, not just bonds. So that's kind of neat. You could have done this to get with amortization table information. Okay, so this is actually kind of neat. What you could do is find the total interest inclusive and total principal paid at the end of certain periods. So between the 7th and 9th period, let's get the total interest and principal. We do the same thing. I'm going to clear the TVM and re-input this stuff. and N3 interest 4,000, payment 100,000, payment 100,000, redemption, compute present value. Okay. Now do the same thing, second step, except we start at 7, end at 9. And then, well, let's check our answers. So first of all, they give you the outstanding balance at the end of the period you entered. So this is correct, 101,913.87. I'm sorry, this is the ninth row, ninth period. So this is correct. 100,970.61. We're off by 16 cents, or they're off by 16 cents. Again, it's negative because that's what this doesn't give you the addition of all these outstanding balances. That's makes no sense. Why would we ever want to add these up? But you might want to know how much total principal you've repaid in number of periods. So let's check that. 888.49 principal pay at the end of the second period. 915.15 principal paid at the end of the eighth period. And then the ninth period, 942.60. Lo and behold, it's correct. Off by 2 pennies, but that's fine. And let's check the total interest. Oh, 311.51, 308.45, 305, 740. Lo and behold, 925.377, off by 2 pennies at. Okay, so yeah, so sorry, this should be a plus, so let me just take a minute to fix that. Yeah, these are made in LaTeX, if you're wondering. Typesetting program, really nice. You can do this in PowerPoint too, if you really want to make fancy PowerPoint stuff. So remember, this is the price of my bond, right? And just plug and chug into the formula for A and J. And this gives us a nice formula for price minus redemption if you just do a little bit of algebra. And remember, if the price is smaller than the redemption, then minus this is the amount of discount the bond is purchased at. Which is basically this one here. And if the bond is bought at a premium and the price is bigger than redemption, then this is the actual amount of premium the bond is bought, FR minus C. All right. All right, so last example using these formulas. So yeah, maybe to make this a little clearer, let me do this. Clear. A second. Good get. Well, all right, so if the bond is bought at a premium, then the bond premium is going to be this here. This is really what I meant, FR minus CJ. A and J. If the bond is bought at a discount, then this here is the bond discount. CJ minus F R A and J. Right. So let's do a exam. Actually, this is I think basically one of the sample FMs, exam FM questions. If not, it's almost identical to one of them. So it is basically uh, um, yeah, it's basically this one here that we're doing. Numbers are a little different, but we're basically given a 40-year bond purchased at discount. We're given the amount for accumulation of discount in these two periods, and they're going to use that to calculate the amount of discount for the bond. It's the bond, the amount of discount that the bonds discount, the amount of discount that the bond was purchased. All right, so maybe word it a tiny bit differently. The amount of amortization of discount immediately after the sixth coupon is 685.33. Immediately after the 12th coupon is 755.32. So this is a weird question because you are given hardly any information and you just have to use what you're given. No other tools. And we're given the bond is bought at a discount, so assuming it's bought at a discount. All right, so let's first write what we're trying to find. Trying to find the amount of discount that the bond is bought at. So this exactly is what you're trying to find. You're trying to find exactly this quantity. Yeah. Okay, so what are we given? So let's go back here. So the principal we're paid is 685.33. Or rather, it's actually going to be negative because the bond is bought at a discount. So it's telling you it's minus 685.33. So this is and just plop into the formula here. We don't know a whole lot, fortunately, but we know N is 40 at least. We know T is 6. Sorry, N is 80 here. Yeah, so we do know N is 80, so at least given that. 40-year, 86-month period. We don't know anything else. Okay, so what is this equal to? Pop into the formula. R minus C J. Well, plus J. So principal were paid after 6 periods. 6 month periods, not 8. So 80 minus 6 plus 1 is 70. So and likewise, we are given what else are we given? Um, yeah, same thing, but for the 12th, um, yeah, so it doesn't say it's 6 month coupon payments, but unless otherwise stated. So after the 12th 6 month period, it's minus 753.13. This equals FR minus CJ. Right, so same thing, 80 except minus 12 now. 1, and that's of course 69. All right, so the thing to do, and the only thing you can really is divide both of these. Let me do this. Move this over a bit. Yeah, so I'm going to just divide. So this equals principal paid after 12. So yeah, we're going to take, you can do one, just divide one by the other. It doesn't matter which one to do. I have written this on my notes, 753.13 over 685.33. So let's, yeah, I guess why not? Let's do that. So dividing, we get, right. It is a good idea because we cancel this whole mess that we don't know. We don't know what any of these stuff is. What any of this is, FR minus CJ, so we can get rid of that basically. So minus 753.13. So some of these problems you can get away with minus signs and forgetting that it's a discount and therefore principal pays minus. A lot of these problems on exam FN you cannot. So, all right, so what is this? 753 minus in second. Minus is minus cancel. All right, 1 point, yeah, 1.099. And so this is going to be 1 over 1 plus j to the minus minus 6. So of course, the same thing as 1 plus j to the 6th. Raise this to the 1 over 6. And we get the following. J, sorry, raise this to the 1 over 6. Little off here, 1, 5. Give me a second. Uh, so it's 755, not 750. Yeah, 755, not 7. That that's why I'm getting numbers a little bit off from what my notes have. So yeah, this is that. This is better. 1.1 basically. 1.11. All right, raise this to 1 over 6. 0.0163, basically 0.016. You wanna, yeah. So that's my yield rate, and now we're actually almost done, right? Because um, what did we need to find? This is what I need to find right here. So I know my yield rate now. 0.0163. So now I just need to find CJ minus FR, and we can do that using either one of them. So I know my yield rate, so let's just yeah, let's just use this red. So yeah, I need CJ minus FR, and everything makes sense with the minus, so I'm going to minus both sides. So CJ minus FR equals 685.3 times 1.0163. 75, just multiplying by this here. Let's see what that is. It's 75 times 685, 2303. Yeah, 2303, 30, 2303. All right, so now we're done, right? Because now we just pop into the calculator. Got this. So yeah, pretty easy problem. Um, doesn't want to stay up. Uh, 2303, 6 months. All right, so yeah, so payment 80 and 1.63 interest present value 102,561.90. That's the answer. All right, hopefully that helped. So take care. Bye-bye.